All right, let's take a look at number 2. For number 2, we're given that a particle moves along the line, so its position anytime where t is greater than or equal to 0. So we want to keep that in mind. Given by this function, where s is measured in meters, t is in seconds. So we want to find the displacement during the first 5 seconds. So that's just the change in position from 0 to 5. To do that, we're going to do s of 5 minus s of 0. Right, position after 5 seconds minus the position, our initial position when t is 0. So s of 5, we put 5 in there, we get 5 squared minus 4 times 5 plus 5. That's going to give us 10. And s of 0, if we put 0 in for t, we're just going to get 5 out. So our displacement is going to be 10 minus 5, which is 5 meters. Part B asks us, find the average velocity during the first 5 seconds. So average velocity, that just average rate of change, we're taking the rate of change of the position over time. So we're taking s of 5 minus s of 0, that displacement, over the change in time. And so the first part, we found the change in distance. That was our displacement. Average velocity is just taking that change in distance divided by the change in time. So we have 5 divided by 5, which is going to give us 1 meter per second. That's our average velocity. For part C, it's asking for the instantaneous velocity when t is 4. So we want to figure out what's the velocity when t is 4. We don't have the equation yet, so we want to figure out the velocity equation, and then just substitute 4 in for t. So velocity is going to be 2t minus 4. So our velocity when t is 4 is going to be 8 minus 4, or 4 meters per second. And so although the average velocity over that interval from 0 to 5 was 1 meters per second, the instantaneous velocity, the velocity at that specific time, is 4 meters per second. And then we want to find the acceleration at t equals 4, so we need to figure out the acceleration equation first. That's just going to be the derivative of velocity, which is what? 2. That means the acceleration is always 2, right? There's no variable. It's a constant acceleration. So no matter what we put in for t, our acceleration is always going to be 2 meters per second squared. Part E, what values of t does the particle change direction? So for changing direction, that means that the velocity is changing signs. Right? Velocity is changing signs. Right? Because velocity is positive, it's moving to the right. Velocity is negative, moving to the left. So we want to figure out a number line for the velocity. In order to do that, we need to know when the velocity is 0. Set our velocity equation equal to 0, we get t equals 2. Now, we can't just assume that it changes at 2. We want to check to make sure, because in some cases it may not. But if we put 1 in for t, we're going to get a negative velocity. If we put 3 in for t, we're going to get a positive velocity. So it does change at t equals 2. Where is the particle when s is at a minimum? So if we want to find the minimum of something, we've been working on that for a while now. How do we know when something has a minimum? Derivative has to change from negative to positive. So in this case, velocity has to change from negative to positive. Well, we can use that number line we just looked at. when t equals 2, it changes from negative to positive, right? The velocity changes. So this is going to give us a local minimum. But we want to look at the absolute minimum here. Is this the absolute smallest value? So if we have any endpoints, we want to check that. Remember, up here, it said when t is greater than or equal to 0. So we want to check that initial position as well as the position at 2. So s of 0 and s of 2. Well, we already figured out s of 0 was equal to 5, right? If we put 0 into that equation. S of 2, we get 2 squared minus 8 plus 5. We get 1 for this one. So that is going to be our absolute minimum. It's going to be 1 meter. Because it's asking where it is, not the time when it's at its minimum. So we have to plug that in. Well, just keep that in mind when you're finding like an absolute min or absolute max. You want to check endpoints if there are any.